Okay, so welcome to today's class again. We have been given this problem to solve for mole fraction. So we have two keywords here that makes up this particular word that says mole fraction. So firstly, what is a mole? In chemistry, we can say that, or mathematically, we can say mole with a small n is the relationship between mass and molar mass. So mole is the relationship between mass and molar mass. What is the relationship? That is what we are talking about. Right here, this become the relationship. This is what divides both mass and that of molar mass. And also we can say that mole is the unit of chemistry that is because mostly in all calculation somehow we hear about mole somehow. So mostly we can say that mole is the unit of chemistry. Okay, so what about fraction? If you were told by someone, maybe your crush or maybe anyone of your family member, what is fraction? It's something that can be expressed in a division form, like you can see right here. So for instance, if we were to say this, or say 2 divide 4, this becomes a fraction. It divides number in this scenario. So we say mole fraction. So when we are solving for mole fraction, we will have a number being placed up in the numerator, likewise a number being placed down in the denominator. So this that will be right up here will be referred to as mole of the solute. So right up here will be mole of the solute. Then down here will be mole of the solution. And we know very well that a solution contains solute plus solvent. It gives us solution. So it also means that in the solution aspect, we will have solute there and solvent. Likewise, we have solvent and solute here and solute right down here. So solute will appear 2 different times in mole fraction because a solution contains both a solute and that of a solvent. Okay, so I hope you have understood that. So we read a question. A solution is prepared by dissolving 20 grams of sodium hydroxide. And sodium hydroxide is a strong base. If you have ever done acid, bases, and salt, you will get to understand that sodium hydroxide is a strong base. And 8 pH, it has a specific pH value. If you have done that in a lab, you will understand that. A solution is prepared by dissolving 20 grams of sodium hydroxide in 180 grams of water, chemically called H2O. So this is the formula for water. And so calculate the mole fraction of NaOH and H2O. So in doing this, you have to get a clue. You have 2 different compounds. You have sodium hydroxide and you have H2O. So for those compounds, this, like I said, is a strong base. Sodium hydroxide is a strong base. And for water can serve as either a base or an acid based in its chemical reaction or where it has been placed. So water can serve as an acid or a base. And if something can serve as both acid and base, that can be referred to as an alphoteric substance or substances, right? So water is not always neutral. It depends the reaction in which it has been formed in. Okay, so let's keep it moving. We will take this sodium hydroxide. We first try to decompose it, have this compound came about. Because we have to have the cloak on something that has already been established. So you have sodium hydroxide, which is NaOH. But have you ever asked yourself how this compound NaOH was being formulated or how it came about? Have you? If not, then you have to know this today. So sodium is an element of group 1, and it has a charge of positive. We say all elements in group 1 have positive charges. That is because they want to lose or give away 1 electron in order to certify or obey the duplex or the octet rule, right? So when you look here, certain charge is actually positive, meaning it's +1. So if we add sodium to that of hydroxide, which is OH, so this now becomes sodium anion because of this charge right here. For this compound, is a neutral compound because it has no charge. So for this, it becomes a positive anion of sodium because of its charge. So if you are to add sodium plus OH, you know fully well that we have 3 different elements here. We have NaOH and that of, you have Na as sodium, you have O as oxygen, and you have H as hydrogen. So we have 3 different elements that formulated or form this particular compound. So Na ion plus OH plus OH plus OH. Wow, this micro is not writing. Plus OH minus. So if you add Na plus OH minus, it gives us something we call sodium hydroxide, NaOH. But here comes another question. How do you think this hydroxide ion was being formed? It's very simple. Like I said in one of my videos, if you see an element or a compound that contains a negative charge, it tells that. So if you see an element or a compound that contains negative charge, it tells that that element or compound wants to gain an electron or wants to gain electrons. So let's say for instance we have fluorine. Fluorine is one of the halogens. It's in group 7, or we say group 17 of the periodic table. Chlorine is in group 7, and you see negative charge right here, it tells that chlorine wants to accept one electron in order to obey or to satisfy the Author's rule. Since chlorine is equal to 7, 1 to make it 8, this one it means it becomes negative here. It's equal to gain or to accept. So definitely chlorine has a negative charge. So we come right here. This is a compound, an ionic. This is a compound right here, as you can see right here. This is a compound because this charge is here also. So this is an anion, as you can see up here. And we say a compound with a positive charge is called cation. And those with negative charges or charge is called an ion. So as you can see right here, this is negative, this is positive. So this actually should have been H2O. It should have been H2O. But it loses one of its hydrogen. We have 2 H here and there is 1 H here. And we know fully well that for oxygen, it has the ability to form 2 bonds. But in this case here, it's not forming 2 bonds right here because only 1 H being linked right here. So we say, oh, it's -2 because it's in XYZ group and it can accept 2 more to make it 8. Oxygen is in group 6 of the periodic table. So 2 to make it 8, it becomes negative. It wants to gain electron. So for H is positive. So to bond this to this, you need 2 of H because the 2 right here for H, oxygen will be able to bond with it. Unlike here, you need to have 1 H here and a negative sign here. So it tells that this can still accept 1 more to make it H2O. So when it accepts, then this charge lost from there, it becomes H2O. So in my next video, I will give an in-depth analysis on ionic and covalent bonding. Okay, so it was how this compound was being formulated as NaOH. When sodium and hydroxide ion reacted, this form NaOH as a neutral compound. There is no charge here. +1 and -1 here. 1, let's say 1 is here. +1 minus 1. 1 minus 1 gave us what? 0. So that's why there's no charge right here. So in our next video, we will try to elaborate on that more. Okay, so I hope you have a little clue on that so we can now solve this problem. A solution is prepared by dissolving 20 grams of sodium hydroxide in 180 grams of water, which is H2O. Calculate the mole fraction of sodium hydroxide in water. Calculate the mole fraction of sodium hydroxide in water. So we can say theta. You should always learn to collect the data whenever you are given a problem to solve. I'm not talking about Lone Star data or orange data. This was a mathematical stuff. Okay, but I get that fun. So a solution is prepared by dissolving 20 grams of water. So 20 grams here we see this G here, tells us is mass. But mass is being placed in gram. So we can say the mass of what? Sodium hydroxide. We can just place something like this. NaOH is equal to 20 grams, right? In 180 grams of water. So logically, it tells you that this is a solute, wherein this is the solvent, because prepare by dissolving 20 grams. You dissolve this in this solute and solvent. So we say the mass of water mass of H2O is equal to 180 grams. Calculate the mole fraction of sodium hydroxide and H2O. Do we know the mole fraction of both H2O and that of sodium hydroxide? No. So we can say mole fraction is mostly represented as X. Mole fraction is mostly represented as X. And we can write this mole fraction of what? Of NaOH is equal to question mark. Mole fraction of H2O is equal to question mark because we don't know them, right? Okay, so the next step is to solve. We can say solution. We make this short, put this arrow here, meaning step continue in spelling. So solution says calculate the mole fraction of NaOH. To calculate for mole fraction, we can say that mole fraction X is equal to mole of solute divided by the total mole of the solution. Divided by the total mole of solution. And you know fully well that solution contains both a solute and that of a solvent. So in here we have a value of sodium hydroxide, which is the solute, and a value of H2O, which is the solvent. Okay, so to reach at this point, we firstly have to solve for the mole of each of those compounds. And how do we find mole? So we can say finding the mole of sodium hydroxide first, finding the mole, and we said that mole is mostly represented as small n, finding the mole of sodium hydroxide, finding the mole of sodium hydroxide. What is the formula for mole? We can say that mole is equal to mass over molar mass. So this becomes the formula for mole. Remember, this is mole is small n. Mole is equal to mass over molar mass. And here we say finding the mole of sodium hydroxide. So in this problem, the mass of sodium hydroxide is 20 grams. So we can insert 20 grams here. And the next one is the molar mass of sodium hydroxide. Do we have the molar mass of sodium hydroxide? Do we have that? No. We don't have it. But since we have been given this compound, we can solve for the molar mass. How is that possible? It's very easy, so you just have to pay keen attention. To solve for the molar mass of any compound, you should firstly know the mass number of that compound and also the subscript of that compound. When I say subscript, example, we say H2O. this 2 becomes the subscript. And it was something that, let's say, if we have H plus, this become the superscript. So superscript is up and subscript is being placed down, hanging. Hope you get that correctly. So to find the molar mass of sodium hydroxide, like I said, we have 3 elements here: sodium, Na, oxygen, and hydrogen. You should first break them apart and know their mass number, right? So here we can say Na plus O plus H. Sodium plus oxygen plus hydrogen. We can now put that together to solve for it. So you can visit the periodic table, or in short, you have to know the mass number of the first 20 elements, right? So sodium, like I said, is in group 1, and the atomic number is 11, wherein the mass number is 23. So I will do a next video concerning proton, neutron, and electrons, so you understand how mass numbers are being formed or how they came about. So right here, sodium is in group 1. The mass number here is 23, or some table will say 22.98 or 22.99. If that is being run up, it becomes 23. So you say parenthesis open, you say parenthesis open, how many sodium is being placed here? So there is just 1. There is an invisible 1 here, but you can't see that. For us as chemists, we see that. So we can put 1 right here. We say 1 times. What's the mass number of sodium? We say it's 23. So you say 23. Okay? So if there was 2 right here, it would be 2 times 23. Hope you get that clearly. Then we say plus. But when they say open, Oya has 1 here, right? So you already seen 1 times. What is the mass number of oxygen? Oxygen is 16 as the mass number, and it can be formed in group 6 of the periodic table. And oxygen has 2 lone pairs. Excuse me? Oxygen is being placed in group 6 or group 16 of the periodic table. And oxygen has, how many lone pair does oxygen have? If you were asked by someone how many lone pair oxygen has, can you go about telling me how many lone pair does oxygen have? Because the first here it takes 2, then the next one is it takes 8, but since oxygen need balance 6 more to make it 8, so 2 and 6. So you put this one there, you put 4, 5, and 6. So 2 become vacant is the bond that it can form. So that's it. So 1 time 16 10, we say plus. H is 1 here. We say 1 times. What the mass number of hydrogen? The mass number of hydrogen and that of the atomic number are the same because it just have 1 proton. So we say this. We sum them. 1 times 23. 23 plus 1 times 16. 16. 1 times 1 is 1. So you add them. 23 plus 16. 23 plus 16 plus 1. It gives us 40. And we say to find molar mass, The unit is gram per mole. Gram is gram per mole. Why? Because we can say mole is equal to mass or molar mass. To make this guy a structure right here, cross multiply this time this is this time there is this. So we can say M this is equal to the mass. To make this guy a structure right here, you divide both sides by what? By mole, right? By mole and mole. Take it out this level what? Mass and mole. So this is in gram, this is in what? Mole. So it was how the unit for molar mass become gram per mole. Hope you get that correctly. It's very simple. Okay, so this becomes the mass number, the molecular weight or the molar mass of the compound sodium hydroxide, MOL. So here now, we now have the molar mass of sodium hydroxide. We can place it right on here. You say 40 gram per mole. So the next thing is we have gram here and gram here. This cancel this 11 mole. So the unit will just be mole. 20 divided by 40. 20 divided 40. It gives us 105. So this become, it becomes 0.5 mole MOL. So 0.5 is the mole of this if it's soft. So the next step is we can also find a mole of water. To do that, let us erase this side. We can say finding the mole of H2O. We say mole is equal to mass over molar mass. Remember, we are finding the mole of water. This becomes the formula to find mole. We find the mole of water. So what's the mass of water? It's 118 as we wrote it right here. So we can put 100 in. We can place 180 gram divided by what is the molar mass of water? Like we saw for sodium hydroxide, we can do the same. So for here, we only have two elements, hydrogen and that of oxygen. So the sulfur that we separate them again, we can say H plus O. H is element 1, like I said, it has a mass number of 1 and that of the atomic number of 1. So for this, it's just 1 times 1 plus. We say for oxygen, it is 16 and how many, excuse me, rather, H here is 2, right? It's 2. So we can say 2 times 1. 1 is the mass number and 2 is this that is being placed right here. The substrate of hydrogen is 2 plus O here is what? Is 1. So we can say 1 times, what is the value for O? The mass number is 16. So we say 16. 2 times 1 is 2. 1 times 16 is 16. 2 plus 16 give us what? 18. So the mass number of water is always 18 gram per mole. It's always. So we have that 18 now. We have that 18. We can place it right at the bottom. Say 18 gram per mole. So gram cancel gram. 180 divided by 18, it gives us 10. What is a unit? It's mole. It gives us 10 mole. So the mole here for water is 10. So we cannot get to the actual problem because it says calculate the mole fraction of sodium hydroxide in water, not just the mole. We did this because before you get to mole fraction, you should first have the mole of each of those compounds. And before you get to God, the Bible says it should pass through his son. Right? Okay, so if I get a scenario. So this becomes the mole for water, and this is what we call sodium hydroxide. So this is the mole of the solute, this is the mole of the solvent. So if you add this to this, it gives you the mole of the solution, because solute plus solvent gives a solution. So if you add this and this, it gives the total mole, which will be 10.5. It becomes the total mole of the solution. Okay. So we can now erase to find the mole fraction of NaOH. I will find one, which is NaOH, and you could have found H2O, right? So we can erase this side right here. We can erase this side to say, we can say finding the mole fraction is X. Remember that? Finding the mole fraction of what? Of NaOH. Remember, X is mole fraction of Na. Can erase this a little bit. Finding the mole fraction of NaOH. So we are about to find the mole fraction of NaOH. Firstly, I said mole fraction is equal to the mole of the solute divided by the mole of the solution. And we say the solution contains both solute and solvent. So it tells that we're going to add this and this to get all the total mole of the solution. So we can now write the formula. Mole fraction X is equal to mole of solute, or if we spell everything out, we say mole of solute, but to make it short, we just say mole of solute divide mole of solution. Get one thing in mind, or get one thing clear, is that mole fraction does not have a unit. Why? Because it's dimensionless. It does not have a unit. For that, you are going to see it with your eyes as we solve the problem. So I'm not gossiping you. Okay? So we say mole of solute. What is the solute in this problem? We said it was sodium hydroxide. And what was the mole that we got for sodium hydroxide? It's this red, 0.5, as you can see here. So we're just going to take this 0.5. We say divide, and we say mole of solution. Solution contains both solute and solvent. It means that right here we'll have 0.5 plus 10. Solute and solvent is the solution right there. So you say mole of solution, or we say the total mole of the solution. Get that clear, man? It's very simple, right? So the mole of the solute, this guy contains solute and solvent, or you could say mole fraction is equal to mole of solute divided by the mole of the solute plus solvent. It's not that easy? Yes, it is. Okay, so we can say the solute here is 0.5 plus what the solvent there is 10. Is 10 mole. No put unit there, is 10 mole. So 0.5 with this constant, we can write 0.5. Or let's bring this up here. We can draw an arrow to to bring this right up here. We say 0.5 divide 0.5 mole. Let us put mole right here. 0.5 mole plus 10 mole, a case or 10.5 mole. Don't say mole plus mole give you mole square or 2 mole. No, here just be mole, right? It's not times we are doing that. So if you divide 0.5 by 10.5, first thing you notice that we have more up here and more down here. Definitely they are going to cancel. So this more will cancel this more. So we can say equal 0.5 divide 10.5, a case of 0.047. 0.047, or we can say 0.05 because this number after 4 is greater than 5, so we can round that up, or is greater than 4, we can round that up, so we can say 0.05. So any of those ones are correct, this and this. So this is the answer, right? So this become the mole of sodium hydroxide. So go ahead and found the mole of H2O using the same concept. For that H2O, you put H2O value which was, or we is 10, so you're going to put 10 up here. And for here, you're going to maintain this, the same figure here, because this is the solvent, the solute. So just put 10 up here and do your calculation. Hope you get that clear. Keep following my page and don't forget to subscribe. Invite people to follow. Then chemistry with Amos, and you have no heartbreak with your loved one. I'm going to give you different method in solving for mole fraction. Maybe you don't want to use this formula as a whole to solve for mole fraction, right? You just want to condense everything to see how best you can be able to solve for mole fraction. So what you do is that you don't want to solve for them separately, like you can find a mole of this, mole of that, you go to the mass. No, that is all delayed. So you don't want to condense everything into a unique formula to solve for mole fraction. So let's keep it moving. So to solve for this, we firstly have to look at this formula that says mole fraction, which is X. We say X is equal to mole of solute divide mole of solution. So when you look right here, you will understand that solute, or the mole of solute, or logically we can say mole right here, mole is equal to mass over molar mass. So mole is equal to mass divide molar mass. And when you look here, you have mole right here. So it tells that anywhere you see mole, you can reciprocate that with mass over molar mass, right? Okay, so we can try to do that. So once we see mole here, we're going to replace mass over molar mass, because mole simply means mass over molar mass. So this mole right here, it becomes mass divide molar mass. So that becomes mass over molar mass. And remember, we should maintain this division sign right here. We should maintain this. This division sign is still being placed here. It is different. It comes from more formula. So the general division sign, which is this, it should be maintained. So we can draw that right here. And we have more here as a whole in this denominator. So we can just repeat the formula that says again, mole is equal to mass divided by molar mass. Okay, so it's very easy, as you can see that. So here now, we are not solving separately. We are trying to condense that formula into a unique one to have a better result as the first one. So we say mole of the solute, and the solute here is sodium hydroxide, right? We have left this formula out. We're not dealing with this. So mole fraction, our new formula now is this one right here, not this one any longer. So for this, we are not using this again. We are not using this one to solve, right? So what is the mass of the solute? The solute is this, is 20. So we can place 20 right here. We say divide. What is the molar mass of the solute, which is sodium hydroxide that we solve for? We say it's 40, right? It was 40, so it's 40 gram per mole. We'll divide this by the general division sign. What is the mass of the solute again? What is the mass of the solute? What is the mass of the solute? And we know fully aware that in this area, this solution contains both solute and that of solvent. So we can put plus right here, and this can be repeated, and this can be repeated, because this is the mole of the solute, and this is the mole of the solute also, plus we need to add a mole of the solvent, right? Giving us a solution. So we can say the mass over molar mass. Don't get this confused. Solute plus solvent gives us solution. More of the solute, more of the solvent gives us solution. So right here now, that is the solute. It means that this same thing. We're gonna repeat that right here. We say 20 divided by 40 gram per mole, right? And we can say plus, what is the mass of the solvent? What is the mass of the solvent? Excuse me? What is the mole of the solvent that we solve for? The mole for the solvent. What is the mole of the solvent that we solve for? For that, we are not using it again, because we have used a different formula to solve for, right? So here now we say the mass of the solvent is what? 180. We can say 180 gram divided. What is the molar mass of the solvent water? We say it's 18. So it's 18 gram. It's 18 gram, right? Okay. So we can now bring it this way to solve. We can now bring it this way to solve. We can now bring it this way to solve. Okay, so we can bring this at this point. So right here, if we say 20 divided 40, 20 divided 40, it gives us 0.5. Hope you remember that in one of our problems we solved previously, we call that same 0.5. You see so? Okay. So we say mole fraction. This now, we divide this by this, it gives us 0.5. Remember, we should maintain this division sign right here. It's general. Maintain this. We divide this by this, the same figure is 0.5 plus 180 divided by 18. You can say 180 divided 18. It gives us 10. So this becomes 10. 10 what? Is gram, right? So we put gram. Here is what? Here is gram per mole. So we put gram per mole. And we put 7.5 gram per mole. Right? So this two, it has gram per mole. So we have actually gotten to the other step that we used first. Gotten this now, we maintain this right up here as equal sign. We can say 0.5 gram, 0.5 gram per mole. If you add this and this, it gives us something we call 10.5 gram per mole. So it tells that this right here is gram, it cancels, this cancels, mole cancels mole, so there's no unit as a whole. So mole fraction is dimensionless, meaning it has no unit. So if you divide 0.5 by 10, I would say 0.5 divide 10.5. So it gives all our C answer to be 0.047, or we say 0.05 for run this. So this is the answer. So it has no unit because it's dimensionless. All those units in there cancel. So you can give this a try by solving for the mole fraction of water using the same step. It's very easy, just for the step and you're gonna learn. So thank you.